if you stand on a beach and just look out over the ocean, you see the horizon, right?
Right.
It looks like this hard physical line, an absolute edge. Like you genuinely feel like if you just sailed far enough, you'd hit a wall or drop right off the earth.
Oh, absolutely. It's a deeply ingrained human instinct to look for boundaries. We're just sort of desperate to know where things begin and where they finally end.
Right. And then you look straight up and you see this massive, blue dome stretching over your head, and another edge, a ceiling.
Yeah.
But as we know, the closer you get to a horizon, the more it keeps moving away from you. And that is the exact phenomenon we are getting into today. We are taking a deep dive into the ultimate edge of the universe.
We are covering an incredible amount of space today, literally and figuratively.
Seriously. So we're going to start right here, with the blue sky directly above us, and then push outward to the absolute furthest limits of the cosmos. And our specific mission today is we really want to simplify this previous deep dive for a mixed audience. We're taking a stack of truly mind-bending cosmic concepts and breaking them down so they're simple, relatable, and just totally fascinating.
Yeah, you definitely do not need an astrophysics degree to follow along with us today.
Not at all. So for you listening, our sources include the brilliant work of astrophysicist Paul M. Sutter, some historical texts detailing medieval Islamic astronomy, and these really profound scriptural traditions that map out the spiritual and physical boundaries of the heavens.
Which is great because blending modern science with that historical cosmology, it gives us a much clearer picture of how humanity has historically tried to comprehend the infinite.
Exactly. So to talk about the edge of the universe, we actually need to start with the edge of our own planet, because we look up every day, but I think we often take for granted what the sky actually is.
Oh, for sure.
Scientifically, it's obviously not a solid dome. It's this multi-layered atmospheric envelope. You've got the troposphere where our weather happens, the stratosphere with the ozone layer, the mesosphere, the thermosphere.
And finally, the exosphere, which just sort of fades out into the vacuum of space.
Right.
And the delicate nature of that envelope is literally what makes life possible.
Right.
Without those specific layers of gas, our oceans would just boil off, surface temperatures would swing wildly from freezing to boiling. Life as we know it simply would not exist.
And on top of all that life-saving utility, it gives us that incredible blue color. Let's actually unpack the mechanics of that really quickly for anyone who might have, forgotten their high school physics.
Good idea.
So the sunlight coming at us looks white, but it actually contains all the colors of the rainbow, right? And when that sunlight hits our atmosphere, it crashes into billions of tiny gas molecules.
Right, because light travels in waves, and blue light travels in these shorter, smaller, choppier waves.
Exactly. And because of that shape, the blue light hits those gas molecules and just gets scattered in every single direction, almost like a pinball bouncing around the atmosphere. That's a process called Rayleigh scattering.
Which, by the way, also perfectly explains why sunsets are red.
Oh, right.
Yeah, when the sun is sitting really low on the horizon, its light has to travel through a much thicker slice of the atmosphere to reach your eyes. So by the time that light gets to you, almost all of the short blue waves have been completely scattered away in other directions.
Leaving just the red.
Exactly. The only waves long enough to slice straight through that thick atmospheric haze are the longer waves, the reds and the oranges.
It's just visually stunning. But the sources we're looking at today bring up a really interesting intersection between this physical science and historical scriptural texts.
They do, specifically within Quranic cosmology. If you look at chapters 21 and 50 of the Quran, the sky is explicitly referred to as a protected ceiling that was built without flaws.
A protected ceiling.
Yeah. And when you map that ancient poetic description onto modern atmospheric science, the alignment is striking. Take the stratosphere. That is where the ozone layer lives.
Right.
And the ozone layer physically absorbs and blocks lethal ultraviolet radiation from the sun. It is an active shield.
And then you move up to the mesosphere, which acts as a literal kinetic shield. Like, every time you're out at night and you see a shooting star...
You weren't seeing a star at all.
Right. You're watching a meteor hitting the friction of the mesosphere and just burning up completely before it can impact the ground. The atmosphere is doing exactly what a protective ceiling is supposed to do.
Yeah, it operates as a highly dynamic barrier, keeping the surface of the planet safe from, a deeply hostile cosmic environment.
But I want to throw an analogy at you here because reading through these sources raised this kind of philosophical point for me. Think about the Apollo astronauts. When they flew to the moon, they experienced what psychologists now call the overview effect. They looked back at Earth and saw this incredibly fragile blue oasis just suspended in pure black emptiness. There were no visible borders on the land, just a thin blue halo protecting everything we know.
It's a profound image.
It really is. So my question is, should we view the sky merely as a biological necessity, just a lucky combination of gases, or is it fundamentally designed to force us to look up and feel a sense of absolute awe?
Well, that tension between random biology and designed awe, that's a core theme in the Islamic worldview. In fact, those two things are not viewed as separate at all.
Oh, really?
No, they are deeply integrated through the concept of tawhid, which translates to the oneness of God. Within this framework, studying science does not strip the magic or the mystery away from the universe.
It's not like science ruins the poetry.
Exactly. Science is seen as the primary tool used to appreciate the intricate design of the Creator. Studying the chemical makeup of the ozone layer or calculating the exact wavelength of Rayleigh scattering, that is considered a profound act of spiritual reflection. The awe you feel looking at a red sunset is intentionally designed to point your attention towards something infinitely greater than yourself.
Man, that's beautiful. So the sky acts as both a physical shield and a spiritual signpost. But, humanity is curious, so eventually we push past that atmospheric shield, we launch telescopes, satellites, probes out into the deep dark. And modern astrophysics tells us something that kind of breaks the human brain.
That the universe is expanding.
Yes, the universe is expanding, and the immediate question everyone asks is, what is it expanding into? Like, where is the center of this expansion and where is the edge?
And Paul M. Sutter's astrophysical breakdown in our materials addresses this paradox head-on. And he warns us right off the bat that the scientific reality is deeply unsatisfying at first glance.
Unsatisfying is an understatement.
Right, because the scientific consensus is that the Big Bang has no center and the universe has no edge.
Okay, wait, let me push back on this. Because the analogy every single science teacher uses in middle school is the expanding balloon, right? You draw dots on a deflated balloon, you blow it up, and the dots, which are galaxies, get further and further apart.
Yeah, the classic balloon.
Or they use the raisin bread analogy. The dough rises in the oven, the raisins spread out from each other. But if the universe is like a loaf of bread expanding, logic tells us there has to be a crust.
There has to be an edge to the bread.
Exactly. And more importantly, what is the oven that the bread is baking inside of?
Well, Sutter points out that those three-dimensional analogies ultimately fail us, because our brains naturally want to place the universe inside of a larger container.
Right.
To simplify this concept, we actually have to drop a dimension. Let's use the Earth as an analogy.
Okay.
If I ask you, where is the center of the Earth in 3 dimensions?
Yeah.
You would just point straight down, right through the ground to the molten core.
Sure, that makes perfect physical sense.
But consider what happens if I ask you, where is the center of the Earth's 2-dimensional surface?
I see the problem. There isn't one. I mean, we use the equator and the prime meridian to navigate, but humans just completely invented those lines. You could draw a prime meridian straight through your living room if you felt like it.
Exactly. The surface of a sphere does not possess a center point. It simply wraps back around on itself. There is no edge you can fall off and no definitive center you can point to.
Okay, I'm wrapping my head around that.
Our 3-dimensional universe functions mathematically, much like that 2-dimensional surface. It doesn't have an edge. It doesn't have a center. And perhaps most difficult to grasp, there is no outside.
No outside.
The universe is not expanding into an empty void of space. Space itself is the thing that is stretching. The Big Bang was not an explosion that happened in a specific location. It was an explosion of space that happened everywhere all at once.
So the universe isn't a bubble filling up a giant room. The universe is the room, and the room is somehow just generating more room inside of itself.
That's a great way to put it. And it forces us to confront the limits of what we can actually observe from our specific vantage point on Earth. Because light takes time to travel across the vastness of space.
Right.
Whenever you look up into the night sky, you are never seeing the universe as it is right now. You are literally looking back in time. You see the sun as it existed 8 minutes ago. When you look through a telescope at distant galaxies, you are seeing them as they were millions or even billions of years ago.
Which is wild to think about. And that delay creates what astrophysicists call our observable bubble. And the math here is where things get genuinely weird. We know the age of the universe is roughly 13.77 billion years old.
Right.
So common sense tells you that the absolute furthest distance we could possibly see would be 13.77 billion light years away, right? Because light hasn't had enough time to travel any further than that. That measurement is called the Hubble distance.
But our current cosmological model says the universe hasn't just been sitting completely still for 13 billion years. We operate under a model called lambda CDM. To break that down simply, lambda represents dark energy, which is this mysterious force actively pushing the fabric of space apart.
Okay.
And CDM stands for cold dark matter, which is the invisible mass that acts like gravity's glue, trying to hold galaxies together. It's a cosmic tug of war. And dark energy is winning. Space is stretching, and it's stretching faster and faster.
So while that ancient light has been traveling toward our telescopes for 13 billion years, the actual physical space that the light is traveling through has been actively stretching out the entire time.
Yes. When we factor in that massive stretching effect, astrophysicists calculate what is known as the particle horizon. This is the maximum physical distance we can actually see right now. And that horizon is roughly 45 billion light years away.
But wait, if the horizon is 45 billion light years away, but the universe itself is only 13.77 billion years old, doesn't that mean things are moving apart faster than the speed of light? I thought the speed of light was the ultimate unbreakable law of physics.
It absolutely sounds like a violation of physics. The catch is that the speed of light is a strict local speed limit. Nothing can travel through space faster than light. However, the expansion of the universe is the stretching of the fabric of space itself.
No, I see.
The space situated between distant galaxies is multiplying so rapidly that it carries those galaxies away from us at speeds exceeding the speed of light. The galaxies aren't firing their engines, moving through space faster than light. The space between us is just ballooning outward.
That just completely breaks your brain. But mapping a 45 billion light year horizon is a very modern luxury. Imagine standing in the desert 1,000 years ago, looking up at all that vast moving darkness without a space telescope.
Oh, it would be terrifying.
For centuries, the sky was just a giant canvas for bad omens and superstition. Eclipses, comets, shooting stars, people thought the cosmos was constantly threatening them.
And the transition away from that fear brings us to a really pivotal era in the medieval Islamic world, often referred to as the Andalusian and Moraga revolutions in astronomy.
Right.
During this period, medieval scholars initiated a massive paradigm shift. They began aggressively separating natural philosophy and ancient Greek myths from empirical observational science.
They stopped looking at the sky and just guessing based on what Aristotle wrote 2,000 years prior and started rigorously measuring the actual movements of the stars.
Let's look at the astronomer Ali Qureshi as a prime example. He was instrumental in providing empirical evidence for the Earth's rotation, exploring heliocentric ideas centuries before Copernicus. But more importantly, he used the tracking of comets to completely dismantle Aristotelian physics.
Wait, how does tracking a comet break an entire system of physics?
Well, for centuries, the dominant Aristotelian view was that the heavens were made of solid, nested, crystalline spheres.
Like literal glass domes.
Literal glass domes. People believed the sky was composed of these perfect, unchanging, glass-like layers holding the planets and stars. If you saw a comet, the Greeks argued it had to be an atmospheric illusion close to Earth.
Because if it was further out.
Because if a comet was actually out in deep space, its path would crash into those solid crystalline spheres and shatter them. But Qureshi meticulously measured the parallax of comets and used mathematics to prove the comets were, in fact, traveling deep in space, cutting straight across the planetary orbits.
Oh, wow. So by proving a comet was moving freely through deep space, he proved there were no glass spheres. He shattered the crystal ceiling with pure math.
Exactly. Furthermore, he proved the heavens were not unchanging and static, but dynamic and measurable.
The sources outline this transition beautifully, especially the Mascacat collection. It showcases this obsession with meticulous, data-driven observation. The scholars were recording the exact coordinates and appearances of comets and loud meteors with shocking precision.
Yeah.
We can actually lay their records side by side with the Anglo-Saxon chronicles from the exact same era in Europe. While European accounts were sometimes recording meteors as literal fire-breathing dragons in the sky, the Islamic scholars were building a highly accurate mathematical dataset of the cosmos.
And building that dataset actively dismantled the grip of superstition. When you can predict and measure a celestial event, it stops being a terrifying omen.
Which sets the stage for a deeply profound historical anecdote from the life of the Prophet Muhammad. He had an infant son named Ibrahim, who tragically passed away.
Right.
On the exact day his son died, there was a highly visible solar eclipse. Now think about the social dynamics of that moment. It would have been incredibly easy and politically advantageous for a leader to stand up and say, "Look at the sky. The cosmos itself is mourning the loss of my child." The people were completely primed to believe it.
But the Prophet's reaction to that eclipse is a defining moment for the worldview we've been discussing. He explicitly gathered the people and told them that the sun and the moon are merely signs of God, and they do not eclipse for the death or the life of any human being.
He actively rejected the omen in his moment of deepest personal grief.
He did. And we see a similar conceptual duality regarding the stars in Surah al-Mulk in the Quran. The text describes shooting stars poetically as missiles driving away eavesdropping demons, but it also simultaneously describes the stars as adornments, beautifying the sky.
It's that balance again.
Right. The overarching principle scholars derive from these texts was that the cosmos operates on a divine, highly orderly system. It is a system specifically meant to be studied, measured, and marveled at, rather than feared as an arbitrary source of superstitious doom.
It's the crucial transition from looking at the sky in terror to looking at it with a telescope.
Yes.
So modern physics gives us a physical boundary, the observable universe at 45 billion light years. But historical Islamic cosmology conceptualizes a totally different kind of boundary, an ultimate existential limit, like what happens when you reach the absolute edge of creation itself.
To explore that existential boundary, we look to the narrative of the Israa and Mi'raj, commonly known as the night journey.
Right. According to Islamic tradition, the Prophet Muhammad experiences a miraculous night journey where he is transported from Mecca to Jerusalem. And from Jerusalem, he ascends upward through the seven heavens. As he journeys through each layered realm, he meets previous prophets, Adam, Moses, Abraham.
And the journey carries massive spiritual significance for the Islamic faith. During this ascent, the obligatory daily prayers were established. The tradition details how the prayers were negotiated down from 50 daily prayers to 5.
But those 5 retained the spiritual weight and ultimate value of the original 50.
Exactly.
The cosmographical culmination of this entire journey happens in the 7th heaven. He arrives at a structure called the Sidrat al-Muntaha, the lote tree of the utmost boundary. The descriptions found in the Hadith literature are overwhelmingly vivid. The texts describe a massive tree with leaves like the ears of elephants, fruits resembling giant clay jugs, and 4 rivers originating directly from its roots. The entire structure is shrouded in indescribable, pulsating, multicolored lights and an overwhelming angelic presence.
The intensely vivid sensory language is utilized to convey an atmosphere of incomprehensible majesty.
But here's the thing. When a modern listener hears that description, are they supposed to picture a literal, biological, botanical tree floating out in deep space past the furthest galaxies? Or is this a profound metaphor meant to represent a barrier that the human mind simply cannot process?
Well, the key to understanding the nature of the lote tree lies in the linguistics of its name. The word muntaha comes from an Arabic root word "nhe", which translates to termination, or the absolute furthest point. The Sidra al-Muntaha is not just a geographical location or a physical fence. It is an ontological barrier.
Let's break down what an ontological barrier actually means in this context.
Ontology is the study of the fundamental nature of being and existence. So an ontological barrier means a limit to existence itself. It represents the utter limit of what can be known, experienced, or comprehended by any created being. The tradition explicitly notes that even the Archangel Gabriel, who was acting as the prophet's guide through the heavens, could not pass beyond this tree. He had to stop. In the Sufi tradition and broader theological studies, the Sidrat al-Muntaha represents the exact definitive point where the finite, structured physical universe ends and the infinite, uncreated divine begins.
It functions like the spiritual equivalent of a black hole's event horizon. You can approach it, you can witness the majesty of the light bending around it, but whatever exists beyond it operates on fundamental rules that our reality simply does not possess.
The conceptualization of an event horizon is a brilliant way to frame it. It is the absolute boundary between the manifest world that we can observe and measure and the unseen realm that we can only approach through faith.
Let's bring all of these concepts down to earth because we have gone on an absolute journey today. We started right above our heads, exploring the protective blue scattering of our atmosphere, a delicate biological shield that literally burns up space rocks to keep us safe. Then we pushed out to the 45 billion light-year edge of the observable universe, learning how the fabric of space itself is expanding faster than the speed of light.
We examined how medieval astronomers like Ali Kushji measured comets to shatter the myth of Aristotelian glass spheres, replacing the fear of the dark with meticulous empirical observation.
And finally, we traveled to the Sidrat al-Muntaha, the ultimate lote tree marking the sheer ontological edge of human and angelic comprehension.
The ultimate takeaway from these diverse sources is that while the cosmos is unimaginably vast and complex, its vastness doesn't have to make you feel small or overwhelmed. The sky is a unifying sign. Whether you're viewing it through the lens of a high-powered telescope, calculating dark energy, or reading about the heavens in a theological text, it serves the exact same purpose. It invites us to replace our fear of the unknown with wonder, awe, and an endless drive for curiosity.
It is a permanent invitation to keep looking up. I want to leave you with a final thought to mull over today. Think back to that horizon we talked about at the very beginning of the show. The line over the ocean that just keeps moving as you walk toward it. If our observable universe is just a physical bubble restricted by the speed of light, and if there are ultimate existential boundaries we can never cross, like the Sidrat al-Muntaha or the very edge of the particle horizon, what if the universe isn't just stubbornly hiding its secrets from us? What if the very act of reaching for an edge we know we can never touch is exactly what gives human curiosity its meaning?
Reaching for the unattainable might be the entire point of the journey.
Keep your eyes on the horizon. Thanks for taking this deep dive with us.